Just give me a sec while I do this. Right, as I say, I'm going live on my old phone because the other one's charging up at the moment, and it takes a long time because I run it down pretty flat. So I thought I'd go live on here because there's a few issues I talked about in the previous video, and I kind of haven't gone over it again, and obviously I need to do. But we do actually lose a little bit of RPM when we put this under load, right? But now oh yeah, the noise that I was getting earlier was my bearing. What had happened was I'd used WD-40 on it, and it had washed all the bloody grease out of it. Yeah, my bad. So yeah, I'd washed it. I'd basically, the bearing was dry, so it was making strange noises. So anyway, I lubricated it with some oil in a syringe mixed with a bit of grease. Well, as the oil dries out, it'll leave the grease behind and it'll re-lubricate the bearings. So yeah, the WD-40 was not a good idea because it screwed my bearing up. But anyway, I re-lubricated the bearing, and I just wanted to tell you that obviously I've been putting nanocrystalline core material on the coils and on these as well. Now, it's important to remember this because it is a huge asset, and I'll show you what I mean. Right, at the moment we're actually pushing out 1.95 volts. Oh yeah, I've got the RPM meter hooked up onto the magnifying glass. I forgot about that thing. Yeah, I forgot that I could just clip the RPM sensor onto the magnifying glass. I'm getting old, I forget things, you know. So we've got RPM meter going. We're 1817, that's 1818 RPM right now. Oh, let me bring it over here actually. I don't know if I can. I haven't got much room. Can I bring it over here and stick it on the battery? I think I might be able to do. Oh, I'm tangled up with wires. Uh-oh. Oh, this is. Oh, shit. This is. I'm really. Uh-oh, hang on, I'm going to put my phone down a minute. Oh, sorry about this. I was getting tangled up. Alright, just give me a sec. I'm struggling here. I'm trying to pick the phone up now. Right. Oh, stupid thing's flipped on me. Oh, I'm still tangled up. Look at this. I've got my wires all wrapped around everything. Oh, bollocks. Hang on. I am not having a good day. That's my meter probe. That's got tangled up in it. I'll get there eventually. Flipping things. Right, I'm going to bring my RPM meter over here. Hopefully not shorting anything out. Okay, so RPM meter's there. Now, when I put a piece of steel, any magnetic steel, like these bits of shim, when I actually put them, I need to get my. Remember, I'm on the old phone, so the battery doesn't last very long. This thing is crap. Bring my meter over here, so I can look at both things at the same time. I've got the light reflecting right now. There's always something. Right, so we're at 1.97 volts right now. And when you put the steel shims adjacent to the coil, when I'm talking about here, when I put the shims on the plastic, look what happens to the voltage. Look what happens to the RPM. Take it away. It's in my finger. Now the voltage has dropped. What's the RPM? Let's get two of these. Hang on. Right, so if I get two of these metal shims in my fingers, and this is just one side, by the way, just one coil. Put them on the side of the coil like that. What's the RPM and the voltage? Can't seem to get the damn voltage on the screen. Can you see that? Take it away. Okay, right, let's watch the RPM. You'll notice that the RPM starts to actually drop when I take them away. Oh, it's not doing it now. It's the voltage fluctuations I was talking about earlier. Right, this flipping meter, let me just get this right so I don't get light reflecting. Ah, that's better. Right, let's try that again, because I'm getting voltage fluctuations at the moment on the mains. Right, so I'm going to put my shims on this other coil. Let's look at the RPM. Look at the voltage. You see it's climbing. We get more speed, more voltage. I need to back out so I can get everything in. Oops, it's catching. I pushed on it by accident. Ah, stop catching. Right. I take it away. Taking it away. What's the RPM? Ah, it's catching. I'm pushed on it. Ah, don't you start. I don't need to catch because I'll lose all my RPM when that happens. It starts rubbing. Now, interestingly, we get more output. This is one voltage right now. Well, let's go to current. Let's go to current. Oh, what the hell is it? It's catching. Oh, it must be just vibrating, I don't know. Right. What? What is ringing? Something's... Right. Okay, back out a bit because I can't get it all in. Right, put my shims in. Right, current, has it gone up? I think it went up. Oh, I lost a shim now. Where's that one gone? 27 point. Yeah, it went down when I took it away. Right, RPM. Let's try this again. I need to get a lot of these shims on here, but if I glue them on, you can't see the difference, can you? That's why I'm holding them on. Once I stick them in permanently, you can't see the difference. Right, I'm holding it up against the, right in between the coil. Right, 18, oh, it's going up, but RPM is going up. Take it away. Did the current go down? I wasn't looking. Let's try that again. Yeah, current goes up when I put them in, look. Take it out. Current goes down. RPM goes down too. Let's put it on this other coil at the top. Actually, I've got the met glass on the back of there as well, so that tends to circumvent some of this. So I need to stick these on here actually with glue temporarily, because I've got to work out where they need to be so I can 3D print something to hold them in place. So this is the shims there on that bottom coil. Current's gone up. RPM, what is it? Oh, it's gone up as well. Take it away. RPM's not. Oh, it's going up again. Ah, that's strange. I've got these voltage fluctuations which are driving me nuts right now. So let's put it back there while it's climbing anyway. So it's just climbing even faster now. Take it away. At least the output current goes up. That's for definite. Worst case scenario, we're not affecting RPM, but our current's definitely going up. Yeah, take it out. Yeah, you can see the current go down as soon as I take these things out. So that's interesting. So what I've got to do is get a load of these shims. Actually, the ones I took out, the bigger ones, the longer ones, the 25mm ones. I need to stick those on really. So I'm trying to get these back on this magnet on here. I'll just go on stick, will you? When you want them to stick, they don't want to stick. Sorry, I'm over here. Right, I'll put them back on there. For some strange reason they don't want to stick today. I don't know why. Oh, that's better. Right, so yeah, the Met glass makes a big difference. When I stick the Met glass on the back, it would probably make a big difference. Let me find the bigger shims. I think they're in here. I want to try a bigger one. Hang on a minute, I've got to put the phone on my knee. These? Oh, those are, look, those are the ones with the cutout. Just a minute. So, yeah. Right, I've got the bigger shims in here. They're a lot bigger. Let's just try one of these. Let's stick it on. Let's push it on the back of here somewhere. Right, I'm going to go on the back. Take it away. Yeah, we definitely see an input on current, milliamps wise, and the voltage. Let me go back to voltage. I want to be on 20 volt range. Right, what's the voltage when I put this one on the back of it? Right, we're there now. We are almost at 2 volts. Oh, at 2 volts now. What? RPM, what is that? 1833, that's 1834. It's going up. Yeah. Still going up. Take it out. Voltage went down. RPMs, I don't know. The voltage fluctuation is really driving me nuts. At least the voltage has gone down now, so it proves that these do help. Let's put it back. Do it on the back side, then I won't cause that thing to catch. So 2 volts, 1839 RPM. Take it out. Right. So a friend was asking, was talking to me in a comment previously, and he said, "Are you sure the magnetism isn't affecting the bearing?" No, it's not, because the field on the inside is completely collapsed. I mean, if I put my file here, there's no traction around here at all. The bearing has no magnetism, as you can see. If I go right next to the bearing, oops, I'm catching the plastic there. Right, there's no attraction at all, as you can see. So the fields, oops, I'm touching the magnet there directly, but the fields are actually folded in on the inside here. It's collapsed. So on the outside it reflects outwards, but on the inside it's focused inwards towards itself. So you see, if this field on the outside is south, this magnet facing it, this magnet on the side is south. So this deflects the field outwards. But remember, the inside magnet, this one on this side, is north. Oops, is north at this side on the back. Because it's north here, and this magnet here on this side is south, that will pull the north field from here around and collapse it. So this is why the field on the inside is collapsed, but the field on the outside is deflected. So just to explain that, so that's where it's configured. So yeah, I need to cover that because I lost my shim now. Where did I put it? I put it down somewhere. Oh, I must have put it back in the thing. Right, I've got another. Let's get 2 of these big ones. Let's get 2 of these big ones and see what we can do with the. Let's see what happens with 2 of these, because it's about mass as well with these things. Right, I just have to get them on my fingers right. It's awkward holding these things. Right, I'm going to hold it like that now. This is just steel, it's not a magnet. I'm just going to put it next to the coil. Let's see what happens. Right, voltage went up to 2.4. Take it away. The voltage went down. I'm not seeing much of a difference with the RPM. We're all voltage right now anyway. So let's go back to current. Oh, by the way, my bearing's a lot quieter since I put the oil back in it. I can't turn this with one hand very easily. It's not very well balanced, that meter. So on current, right, so let's go put this back on here so I can circumvent some of the losses with these bits of steel. Right, so 27.6 milliamps, take it away. 27.2 milliamps. That's just one coil on one side. So I really need these steel things. I need to be all the way around it really. And I could stick them on like, but I don't want to make a mess. And they are a bit long. I don't know how to mount them actually. I'm trying to figure out the best orientation really. Let's try this way across the back. 18.12 RPM. Something is rubbing. I don't know what it is. Just catching somewhere. It's annoying me. I need to sort that out. Hang on. Oh, I made it worse. Oops. Hang on. Nah, I think I fixed it now. Right. I hate it when things... See, I lost all that RPM just from that catching. So I've got to wait for it to pick up again now. Okay, let's try that again without pushing or anything. Right. So yeah. That... It's interesting that we don't change the RPM much, but the current goes up. So yeah, I need to. I was modelling some things on the SketchUp model to hold these pieces of steel in place, and I had to delete them because I went and changed the coil arrangement because they were in the way. So. That goes to prove that you can start modelling something, then you change something else, then it scraps all the previous things you made. So that's the reason I haven't remodelled anything to hold these shims, because I had to get the coils right first. I had to get the coils right, and then I can start working on where to put the steel shims. Now I'm using the matte glass on the back, but it's debatable whether or not the steel is going to be better than the matte glass. The matte glass should be better, but I don't know. Let me just. I've got the matte glass on the back there. Let's just put this on the back with it. 27.1. Took it away. No change. So the matte glass is very efficient. The matte glass is extremely thin, but it's doing a better job than all of this steel would do. So on the back at least, mind you, it's a weaker field on the edge. Most of the magnetic field is on this side. That's where most of the field is. So when I put this on the side, I get a lot bigger improvement. So yeah. Oops, I've stuck to a magnet now. I don't want to pull my rotor off the thing. Yeah, I hate it when that happens, because if I pull too hard, I could pull the whole assembly off the stand, you see. Could be quite disastrous if that happened, because it could fall on the floor. You know what I mean? Yeah. So anyway, I've just thought I'd play around with this a bit and show you some things I didn't show you before, and also go over this about the screening around the thing. And yeah. So one other thing I could do is put the matte glass actually on the canopy before I wind the coil. Would that help? I don't know. It might do. I'm not sure. Would the matte glass be better under the coil or on top of it? That is something I need to find out, because I haven't determined that yet. I might be able to get the Met glass underneath this coil here because it's wrapped, it's on the top of the plastic. I might be able to get the Met glass to go underneath it, possibly, if there's enough spring left in the wire. I might be able to do a test on this coil here. It's a very flimsy coil, but I would have to experiment with that. But I did find that by putting the Met glass across two coils, right, because the two coils, well, this coil ends and this coil starts, it seemed to work better in the middle than it did when it was over here or over here. That's why I got that one stuck in the middle. But I put this one with it folded so it's sticking out a bit at the top, and this one folds around the coil and it sticks out, it folds around that coil and it doesn't go to the bottom. That seemed to work best like that, really, for some odd reason. So it makes sense that putting the shims on the in between the coil like that would work better. Just makes sense. And take it away again. Yeah. Anyway, so that's enough of my rant. I'm just going on about this. I don't know why I'm bothering, actually, because I'm just covering stuff that I've already covered, really. But I suppose not everybody watches all my videos, so I've got to repeat myself sometimes. Yeah, my phone's getting hot now, and this battery is down to 81% as well. So yeah, I thought I'd go over that because my friend was saying about the magnetism. That's why I wanted to cover it. And a compass, using a compass is impractical because the all this magnetic stuff going around, my compass would just go wild. Probably it would just demagnetize it more than anything, probably. But the shaft is definitely not magnetized. I can prove that by using this ball bearing. Is it gonna roll on this shaft? No, it's not magnetized. And oh yeah, there's something I don't think I've showed you. The frequency. We do, as I say, we do lose a bit of speed when I go from the current setting to volts, and the best way to determine that is to go from current to frequency, because you can see a slight change on frequency. So let's look at the frequency. The frequency is 364 hertz and climbing. Well, 365 hertz. So we do lose a little bit of RPM. So the frequency will show us that. So there is a bit of thermal resistance in the coil, but yeah, we do gain a bit of speed when I take the load off. So there's definitely I haven't got the arrangement of my segments because it's ferrite. I can't do that. It's a solid piece of ferrite, and ideally, oh shit, I can't even get my words out today. I wanted to have them arranged like this, you see, but it would mean cutting dozens and dozens of pieces of thin ferrite discs and sticking them in that arrangement, and I don't fancy spending weeks or days or whatever it is with that black horrible ferrite crap all over me, cutting a bunch of little shims to make that arrangement in my segments. So I've been trying to source some thin ferrite stuff, but it's too expensive to buy, and I can't really find a source really for the right size material for that. The only option would be to design a completely new cutting table, a new ferrite, like this one I use for cutting all my ferrite stuff. I would have to completely redesign this so that it would look a bit more automated, so I could cut little segments off, have an end stop so the thing rolled off the end, and then cut the next one and so on. And I don't want to, I'm just checking my hands for black stuff, because I hate it when I get all that shit all over me. because I have to wash my hands every 5 minutes. Every time I handle the damn thing, I have to go and wash my hands because otherwise I get it on my clothes. You know you know that chair was sat here. You know where the chair was sat here the other day, and I had the cutting table on it. I was cutting that ferrite stuff. After I'd finished, you didn't see this because the stream had ended. But I put the cutting table, I cleaned it, put it down there. I thought, oh, I better put my chair away. I grabbed my chair, took it across the room, put it behind the door, and guess what? I had black stuff all over my arm and my hand. Why? Because the magnet that was next to the chair leg, because the chair's steel, I'd picked up a load of crap and black ferrite dust all over the chair, the metal, the arm, the thing that supports the seat. And I got this stuff all over my flipping arm. That was after I just washed my hands. This is the kind of mess you'd have to deal with. And oh, I just thought, oh shit. And I just went in the bathroom and washed my hands again. So I literally washed my hands twice in 5 minutes. I mean, oh, let me just try and show you. I mean, this chair here, it's steel, right? There was a lot of black stuff all stuck to this. I didn't see it until I picked the damn thing up and got it all over my arm. So yeah, what a friggin' mess it was. That's the reason I don't want to cut ferrite. I really hate doing it. It's not healthy as well, it's hazardous to your health. And I need to put my door stopper back in now. So the vacuum cleaner, robot vacuum, doesn't shut the door behind itself and it pushes everything over, shuts the door, locks itself in, and it can't get out. Right, so yeah, so the actual frequency of the generator is about 370 hertz. Well, 0.369 kilohertz is 370 hertz. So it's actually pretty high frequency. Because of the arrangement, it'd probably be even higher frequency if I had another coil wound on here. But I've actually got them two coils in series, so they're actually working pretty well. There's a slight stepping on there, because of the synchronization. I don't know if I can show you where. I haven't got the appropriate drawing. These drawings are the wrong drawings, because wrong prints, I mean. But because I've got, oh, actually this one's got the magnets. So because we've got these segments are wrong, because these are the other segments are took out. But because we have a coil that's connected to these magnets, right? We have a coil between this magnet and this magnet. So these coils are basically overlapping. So we have a coil around there. We have a coil up between there and there. So we have there's a crossover area in between them. But because I can still wire them in series, because this intersection is still in phase, basically. That's what I'm trying to say. They're still in phase, so they don't cancel each other out. If you get what I'm saying. So yeah. Anyway, I'm gonna go because this battery's gonna need charging up now as well. Right. Thanks for watching.